Hi. So in this episode, we'll be talking about fairness. Okay, so I'm not going to go through the rigorous definition or proof for fairness. If you want that material, please refer to the book by Leslie Lampert, Specifying Systems. So this chapter or this episode will be focusing more on the application of fairness from a practical standpoint. What does that mean, right? And then I'll be doing that using an elevator example, right? And then so I'm trying to specify an elevator system that eventually makes it to the top floor. Okay, so consider this elevator spec, right? Hopefully fairly straightforward, right? So we have defined two actions, up and down, right? So we can go up so long as we're not on the top floor. And then so every time we go up, it's a prime equals to a plus 1. And then we can go down unless we're already at the bottom floor, right? And then when we go down, a prime equals to a minus 1. So the spec is defined to be, well, init and next being up or down, right? So hopefully fairly straightforward. So let's define a liveness property here, right? So starting off simple, right? So we are on the first floor, and then it should lead to the elevator going to the second floor. That's it, right? So the liveness condition is a equals to a leads to a equals to 2. Okay, so now let's try to run this. Okay, so we failed. And then that's basically because we didn't actually provide a fairness description, right? So in the absence of fairness description, the spec permits stuttering, right? What it really means is we are on the first floor, and the model checker simply says, well, the spec, I guess, says that, the next action can be an inaction, right? We simply don't do anything, right? So we're on the first floor, and we'll just stay on the first floor, right? So the system stutters. Okay, so now the liveness property fails, right? Okay, so let's start. How do we fix that, right? So let's start by introducing weak fairness, right? So weak fairness reads like this, right? So I'll take this apart a little bit. So an action in the TLA plus notation is a combination of basically a set of enabling conditions as well as a set of variable updates, right? And then so let's go back to the example here. The enabling condition is when a doesn't equal to the top floor, right? This is the enabling condition, right? So we will only take up, we can only consider going up when a is not already at the top floor. And then there's the variable update, right? So the variable update being, a prime equals to a plus 1, right? And then so my understanding is the enable here refers to the condition part of it, right? The enabling condition part of it, so this part of it, right? So what does that mean, right? So what this really means is, so eventually always the enabling condition of A leads to always eventually A being called, right? And then, or in hopefully more simple terms is, if we're ever stuck in a state, right? So eventually always. So if we're ever stuck in a state where the enabling condition of A is always true, then A must always be called, or always eventually called, right? So if we're stuck in a state, then the enabling condition for the state for the next state must be true, and therefore, this action must be called as well, right? Okay, so so let's update our spec a little bit, right? And then so we want to enable fairness description now for both up and down, right? Okay, so now let's do that, and then let's run this. Oh, good. Now it passes. Okay, but this is not. We want more than that, right? We actually want not just make it to the second floor. We actually want to make it to the top floor, right? Okay, so now let's update the liveness condition to reflect that, right? So now the liveness condition is now going from, we want to verify that we can go from the first floor eventually or leads to the top floor. Okay. It's embarrassing. Okay, we're back. No, actually, let me try to run this again. Okay, sure. But basically what it says is, you know, the condition is it's not satisfied, right? So we can go from 1, 2, 3, then back to 2, then back to, we're sort of stuck in this perpetual loop of being stuck between 2 and 3, right? And then, so why doesn't this work, right? So let's look at the weak fairness condition a little bit more, I guess, closely, right? Because the problem is we're actually not stuck in a single state, right? We're actually stuck on a loop state, basically, right? We're stuck between 2 and 3, right? We're not stuck just on 3, like we were before, right? So before it was stuck between, we're stuck on 1, and then weak fairness can force us to go to this 2. But now we're stuck in a loop, right, between 2 and 3, right? And then so we're no longer stuck in just one state. So this is where strong fairness comes in, right? And then so look at this definition a bit more closely. So there's, you know, the difference really is the first two operator here, right? So in a weak fairness, it's, I guess, eventually always. And then in the strong fairness, it's always eventually, right? And then so my interpretation of this is eventually always means that we're stuck in a state where it will always end up being, you know, in a state where the enabling condition is always true, then the action will trigger. But in strong fairness is somewhat relaxed, right? So always eventually just means that the enabling condition only needs to be true once, right? And then it just needs to be true once. Then, you know, we will always eventually make it to the top floor. Okay, so let's try. Why don't we try to update the spec to reflect that, right? So let's try to do this. Okay, so now I'll try to run again. Oh, but it still fails. So now why is that, right? Okay, so now okay, so we're still stuck in a loop, right? So if we look at the backtrace here, we're still stuck between 1, 2, and 3, 1, 2, 3, and then back to 2, back to 3, and then so we're stuck in a loop between 2 and 3. So why didn't this work, right? Okay, so let's revisit the enabling condition for up, right? So the enabling condition for up is when A is not top, or when we're not at the top floor. That is really the only enabling condition required, right? And then so when we are stuck between you know, a loop between 2 and 3, floor 2 and 3, when, you know, up is actually being called, right? So when we go from 2 to 3, up is being called, right? Thus satisfying the strong fairness requirement. And then we go from 3 back to 2, and then back to 3 again, and then up is being called, right? So the strong fairness requirement as defined here is not actually strong enough, right? What we really want is we want strong fairness on the action up as well as for every single floor, right? So that would be strong enough, right? We want the precondition or the enabling condition to also include being on every single floor, right? And then so if we're on 2, then we must make it to 3. If we're on 3, we must make it to 4, so on and so forth, right? Okay, so now let's update the spec to reflect that, right? Okay, so now the enabling condition, or rather the strong fairness condition, has been updated to say that, you know, for every single floor, except the top floor, right? Because, you know, we're at the top, we don't need to go up again. Then for every single floor that is not the top floor, we want to enable strong fairness on the action up and for that floor as well, right? So now let's call this again, and then now the spec passes.